now we'll focus only on high-level driver part. So high-level drivers are responsible for what? Responsible for taking care of the peripheral. You're not worried about the controller job and all that. So high-level drivers now are in kernel space. Can I call them as peripheral device drivers? Yes, because they have code. They have code that is specific to a peripheral device that application is interested in, isn't it? So these drivers, who will use these drivers? Who will use them? Application. Applications are in user mode, U mode, K mode. Okay. What is the functionality of this code? While writing this code, what pieces of logics you need to write? What are the issues for which you need to write code? If you're writing this, think about it. When you're writing this, let's make an assumption you're writing this. You know that you need to write functionality for accessing the hardware, peripheral device. Apart from that, what you need to write? You need to know how to interact with application. You need to provide an interface through which the application can request that do this operation now, do this operation now, and so on. So there should be a way for the application to interact with this particular driver, send data, receive data, all that, isn't it? That's one. Second, you must now know how to communicate with what? Hardware. Communication with hardware is done by API of low-level driver or the abstraction layer, isn't it? So now, writing this driver is two parts. Two different logics, if you combine, this driver is done. The first logic is interface to an application. You need to provide interface to app. Okay? And then you need to provide interface with interaction with hardware. I'm being more general here. These two are the jobs you need to do. This we do by communicating with that low-level driver. The whole suite is called bus stack. Just now I told you. So this code is specific to bus stack. If the device is connected to PCI, we interact with PCI bus stack. If that is USB, we interact with USB bus stack. I2C or SPI or any bus, we interact with that bus stack. That bus stack includes low-level driver. Yes? Clear? What about this? This is specific to what? This is specific to, important, very important. This is specific to design of who decides how the applications communicate with the kernel services? Kernel design. In Linux, we achieve it through syscalls, isn't it? In most of the operating systems, syscalls. But in microkernels, IPC, because drivers of this type are running as background services or daemons, and communication is done through IPC microkernels. So it is completely up to operating system's design of writing this logic. This logic is specific to OS because OS ultimately provides you an interface through which applications and protected mode services can interact. Clear with this? Now when you use the term Linux device drivers, Windows device drivers, or any book or manual that says Linux VxWorks device drivers, they are focusing on this part. Device drivers are about interaction with hardware. That will not change irrespective of which OS you use. That is completely specific to hardware. What will change from one OS to other is how these two interact. Windows will have its own mechanisms of interaction between these two. And the whole of that procedure is called Windows device driver procedure. It has its own APIs through which these two are interfaced. Linux has its own way, VxWorks may have its own way, some other microkernel may have its own way. Clear with this? The first reference book, Linux Device Drivers, that's what I mentioned. That book talks only about this, not about this. He just touches this part of it, low-level part of it, just to make you familiar that these things internally interact with this. But basically, that book's objective completely is about the high-level drivers, that too, how applications and drivers interact. Okay? So, we'll be exploring this also. Exploring this only one way, you got to be ready to read kernel source. That's the only way to understand and learn this. Right now, there is no book which comprehensively covers all this. Because if a book is written for this kind of thing, there won't be any readers for it. Obviously, that stuff would be easy for people who know this already. So maybe we can expect future some books, but right now, there aren't any books which actually go into implementations of this in complete detail. What I did is I spent time on reading kernel source. Anyone can do that, that's very easy. So, this breakup is clear? Now in Linux, this driver logic, this part of the logic, can be written in three ways. Linux kernel provides three different approaches for us to write this code. Okay. The first approach is called character driver model. The second approach is called block driver model. The third approach is called communication driver model or network driver model. VxWorks may provide 5 approaches. Windows may provide one approach that is completely specific to that OS design. So we have 3 approaches of writing this, which means while writing this code, we have 3 different design approaches we can follow. We can follow approach 1, approach 2, or approach 3. Which approach you choose, it depends on 2 factors. 1, how do you want these two to interact, synchronously or asynchronously? Asynchronous means what? Application will not directly interact with your driver. Instead, it will submit a request and go back. And driver will then carry out the operation. When the operation is done, application will somehow poll for the operation status one way. Other way, driver can send a signal and tell the application your job is done. That's asynchronous. Second, synchronous, where this will make a call to a function here and wait till that function returns. That's called synchronous. Like this, these are simply ways of interaction between these two. These are not specific to any drivers or any buses. These are independent of buses. We call them as Linux driver classes. VxWorks may have 10 classes or some other OS may have 20 classes. Clear with this? So car driver, block driver and network driver are 3 different models of writing high-level driver code in Linux. These models are separated on the basis of how they interact with the applications. And not about any bus, which means a car driver could be on PCI bus, a car driver could be on USB bus, low level, a car driver could be on some other bus. Which bus it belongs to, ultimately that depends on what kind of device it is and physically how it is connected. Nothing to do with car, block and network. Clear? So now, first we'll have to explore from here. We'll have to explore these 3 models of writing code. Then we'll finish this, come down to this. When we come down to this, we ignore this stuff because we're not bothered about how these pieces of code interact with the application because they never do that. Got it? These pieces of code are hidden from the application. These pieces of code are interacting with bus. Okay? Then we'll explore into how they interact with